Yeah, hello guys. You are welcome to Easy Tech Academy. You are welcome. All right. So, with my free time today, I want us to share a knowledge together on mobile charging circuits. Okay. All right. So, if you are new to this account, so I want you to follow this account or subscribe. Okay. And at the end of watching this video, I want you to comment. So give a comment. Okay, so that's when I will know that you are interested so in what I'm posting to you guys. Okay, and try to click on like button. Okay, all right. So guys, so today I want to share with you um a I want us to share knowledge together on mobile charging circuits. Okay, so let me try to switch my camera. So all right, so okay, so concerning mobile charging circuits. Okay, what happens is that I will first of all I will want you to understand uh, like four terms, okay, in charging circuits. Okay, so when you are working on charging circuits, okay, so you have to understand four things. Okay, so first you have to understand what we call fibers, fibers, fibats. Okay, okay, and okay, let me say three and VPH or V system. Okay, all right guys, so in charging circuits, so you have to understand this thing. Okay, so what is fibers? What is fibers? Okay, when we are talking about the fibers, so fibers that's the 5 volts that is coming from your charger. Okay, and fibat, that's the voltage that the charging IC will give out so to charge the battery. So just know that this voltage is coming from charging IC fibat. Okay, so it's in between 3.7 volts to 4.2 volts. Okay, and when we are talking about VPH system, so we see that charging IC give out this voltage also. So especially in this latest mobile phone, so they give out this VPH or V system. Okay, so in such a charging IC, so any charging IC that give out a VPH or V system, just know that if you remove such a charging IC, the phone will not power on. So but when you check your schematics, okay, um if you see that it's not the charging IC that is giving out a free pH or V system. Okay, if you remove that charging IC, the phone will still power on, just that it will not charge. So that's one of the secrets you have to know. Okay, so the V system or VPH, so they are the same thing, just that it is just a schematic terms for different chipset that we have today. So like Qualcomm, MediaTek, that's the MTK. Okay, so MTK is using this. So why Qualcomm is using this? Okay, all right. So they are the same thing. So it's also like 3 volts to 4.2 volts. Okay, so what happens is that, look, let me tell you one thing. You can see that this voltage is corresponded to this V system, the battery, the feedback voltage. Okay, so don't be confused, it's also a battery voltage, so it's still coming out from the charging IC. Okay, but this is what you have to know. This is what you have to know. See, if you are working, if you are close to schematics reading very well, so whenever a signal pass through another process, the name will change. Okay, because why? For example now, for example, um this is our fibers, 5 volts. Yes, so that's the 5 volt that is coming from it's coming from the our charging port. That's our CC. So that's charging connector. It's coming from the charging port. Listen, okay. When this 5 volts, you have what we call OVP. That's over OVP IC. That's over voltage protection IC. Okay. In this this work of this OVP is that it serves as a protection. Okay. What is it protecting? So it's monitoring this guy, VBus. If any voltage is more than this 5 volts, okay, if this OVP detects maybe it increased to 6 volts, 7 volts, so anything can happen with your charger, your adapter, whereby it can loot out some voltage. It's a step down. So if that is step down circuit in that adapter is not working very well, anything can happen. And if OVP sense that the voltage is above 5 volts, it will short. It will not allow it to go to mobile PCB. Okay, so that's the work of this OVP, over voltage protection. That is excess voltage protection. Okay, so now listen. Now the output, this voltage coming from VBus, we enter this OVP IC. Okay, and this OVP IC will give out the voltage. So it's also a 5 volts that this VPH will give out and go to what? Charging IC. It will go to charging IC. Okay, all right. So this is where what you have to understand. Okay, when this 5 volts, we already know that what this guy will give out is also 5 volts to the charging IC. So it is charging IC that will now step down to the particular voltage required to charge the battery. You understand? But when this 5 volt pass through this OVP IC, because this 5 volt has passed through another process, you will see something on your schematic like VBus USB, or you can see something like VBus OVP. Hope you understand. Okay, so it's telling you that this VBus has passed through the OVP IC, the process. You have passed through the OVP process. So the OVP have scanned it, have testified it. So because he has passed through another process, the signal is either he had another name to the signal or the signal name change. So that's exactly what happened to this VPH and V system. It's also a VBAT voltage, but because he has passed through another voltage and another process. And what is the process he passed through? There is a coil. Let me use the symbol of a coil. There is a coil that beside the charging IC that we output. This side will be VBAT voltage, and the other side will be VPH voltage. This coil is called buck coil. Okay, because you have passed through the process, so it's also called switching coil. Because you have passed through this process, it's changed to VPH. Okay, so that's why you see that the name change. And this VPH is the one that will go to our mobile PCB, or the section is the one that will supply. It's not the battery voltage. Why? Because the battery voltage, so far the battery voltage is decreasing. Maybe you use your battery voltage, your battery percentage is 100%. Later you reduce to 70% as you are using it. So mind you, maybe this is the full charge voltage, 4.5 volts. That's your 100%. But when the percent is reducing, maybe 4 volts, around 4 volts, you can have like 80%. Okay, like that. So the voltage is reducing. So in order not to be affecting other circuit, that's why he passed through this process and maintain this VPH power so that the other circuit will not be affected when the battery voltage is decreasing. Okay, you understand? So that's the difference between feedback and VPH. But the VPH is produced from feedback voltage. Hope you understand. Okay, all right. So now when you are working on charging section, okay, so you are dealing with two guys. Okay, so we mention the two guys you are dealing with in my next video. Okay, so let me see your reaction in comment section. Let me see your I want to see your reaction. Okay, so I want to know how people are interested. Then I will move to the next section. Okay, all right. So guys, so I will see you in another next class. Okay, all right. So I want to see your reaction in the comment section. Okay, so remember to subscribe if you are new to this channel, and click on like button. Okay, love you guys. So see you in the next video. All right.